what if the real secret to building a $1 million AI product isn't the AI at all? Beat. Okay, let's unpack this. Welcome back. Today, we are doing a deep dive into a really fascinating case study.
Yeah, this one it's incredibly practical. I'm excited.
We're looking at a founder named Nick Seriev. He built this AI product called Clairvo, and it currently generates $1 million in annual revenue.
Which is wild for such a lean setup.
Right. So our mission today is to extract his exact 5-step framework. For you, the listener, we want to look at the actual mechanics of how he pulled this off.
We are diving straight into the deep end here. We'll cover everything from, mining ideas with Claude Code to pricing strategies and even building business moats that are just completely uncopyable.
It's a great roadmap. So let's start with the first step, the problem itself. 90% of builders fail right out of the gate, mostly because they pick what we call warm problems.
Ugh. Yes, the warm problem trap. It's so common.
A warm problem is, well, it's a mild inconvenience, like a slightly messy dashboard,
Or just a clunky user interface. Sure, users might compliment your software if you fix it, but they're never actually going to pay for it.
Exactly. You need a red-hot problem instead.
Right. Something that is actively costing a business millions of dollars right now.
Yeah.
A red-hot problem is basically bleeding cash daily.
So let's look at the specific red-hot problem Clairvo tackled. They analyzed the brutal logistical math of outbound sales.
Oh, man. Cold calling.
Yeah. Forget the actual sales conversation for a second. Just think about the pure friction of dialing. A typical sales rep makes, about 100 calls an hour?
Roughly, yeah. And out of those 100 dials, usually only about 40 people actually pick up the phone. The physical reality of that is just staggering.
60 calls go absolutely nowhere.
Right.
And it isn't just the lost time. It is a massive drain on human momentum.
Oh, completely. The rep is just sitting there. They're listening to endless ringing.
Waiting for a voicemail to beep.
Hanging up, logging the failed call in the CRM.
Styling the next number, the context switching alone just destroys their focus.
Exactly. And that's where Clairvo steps in. They look at that exact operational nightmare.
It's an automated predictive calling system, right?
Yeah.
Right.
The AI handles the dialing, the ringing, the waiting, all of it. It only connects the human sales rep when a real customer actually says hello.
And the outcome of automating that friction was striking. They deployed this for an HVAC company.
Just a standard traditional heating and air business.
Right. And that single integration increased the HVAC company's revenue by 66% in exactly 1 month.
Wow. I mean, 66% top-line growth is basically unheard of for a traditional brick-and-mortar business.
It's massive.
And the underlying mechanics of why this works, they come down to a few core business principles.
Let's break those down.
Sure. First is high lifetime value, or LTV. These clients are paying massive monthly fees indefinitely. Second, it's an underserved traditional market. Tech founders usually just build tools for other tech founders.
But it's an echo chamber.
Exactly. So bringing sophisticated automation to an HVAC call center, that is an absolute blue ocean.
And the third principle is low churn. Once you integrate a logistical system like this, it sticks. But let me ask you this. Why do traditional industries stick with these tools so stubbornly?
Well, because it becomes the backbone of their daily sales operations. When an automated tool runs, the actual logistics of routing calls to your staff, ripping it out means stopping the entire sales floor completely. That downtime is a terrifying thought for any operations manager. They just won't do it.
So the software becomes the actual heartbeat of their sales floor.
Exactly. It pumps the lifeblood of their revenue directly to the reps.
That makes total sense. Now, once you identify a massive, costly problem like that, you have to actually solve it.
Right. The hard part.
And I'll be honest, I still wrestle with over-engineering simple problems myself.
Oh, we all do. It's so tempting.
It really is. It's incredibly tempting to just open up a code editor and start building the very first idea that pops into your head.
Yeah, most developers just jump straight into writing logic. But Nick's team, they inverted that process entirely.
How so?
They used Claude Code, but they didn't ask it to write the app.
Okay.
They asked it to generate between 100 and 300 different ideas to solve the call pickup problem.
300 ideas.
Yeah, they used a very specific prompt architecture to do this. They told Claude to spawn 10 parallel subagents.
And just so we're clear, subagents are simply mini AI assistants working on different parts of a task.
Exactly. So each of those 10 subagents had to generate 10 distinct mechanisms. They didn't just want, slight variations of the same code. They demanded algorithmic ideas, like predictive dialing.
Okay.
They asked for behavioral ideas,
Yeah.
psychological ideas, like altering the exact timing of the call, even time-based solutions.
I look at this like forcing a chess engine to calculate 50 moves deep. You do it so the computer stops playing the obvious, boring beginner openings and actually finds a novel strategy. But this raises a practical question. Why do we need 300 ideas if most of them are terrible?
Because you only need 5 or 6 viable ones to test. When you ask for 300, you exhaust the obvious low-hanging fruit immediately.
Ah, I see.
The sheer volume forces the AI out of its predictable training patterns. It literally has to combine weird concepts just to hit that quota.
Right, you're panning for gold in a massive river of data.
Exactly. You wash away all the generic software concepts to find the actual structural gems.
That's brilliant.
And once they isolated a strong idea, which was dialing multiple numbers simultaneously, they paused.
They didn't just start coding.
Nope, they didn't build it, they simulated it.
This is where the engineering gets really fascinating to me. They fed historical call data into a simulation environment.
Yeah, Claude actually wrote a mock testing ground because they needed to test the predictive pacing safely. Whoa, imagine simulating thousands of calls before writing a single line of real code.
It's wild.
They used an AI to generate synthetic humans who called a synthetic business just to test a synthetic logic routing system. The leverage there is mind-bending.
It changes the entire paradigm of software development.
It really does.
And that simulation immediately revealed a critical routing bug, didn't it?
Oh, big time. Think about it. If the system dials 3 people, expecting 2 to ignore it, what happens if all 3 pick up at the exact same time?
Right. One human sales rep cannot talk to 3 customers at once.
No. And the simulation flagged that instantly. So they went back to Claude and asked for queuing logic.
They defined the fallback behavior.
Yeah.
Pass the first connected call to the active agent immediately. Put the second and third calls in a holding queue, play a brief message, and instantly pass them to the very next free agent on the floor.
Which is standard now, but they avoided a massive real-world customer service disaster by simulating the failure first.
Right. It stress tests the logic in a sandbox.
Exactly. So now we have the winning idea, and we have the successful simulation.
And the natural instinct here is to wrap this in a complex software architecture. You want to use LangChain or Autogen or some heavy agentic framework.
Oh, yeah. Shiny new toys.
Totally.
But the case study says this is a total trap.
Nick's team actually tested over 50 different agent libraries and frameworks.
50.
Yeah.
50 separate architectural setups.
And their final conclusion.
Vanilla Claude Code wins.
Wow.
Heavy wrappers and orchestration layers just slow the underlying model down immensely. What's fascinating here is it's the mechanics of why those frameworks fail. When you add a heavy orchestration layer, it injects its own hidden prompts and arbitrary logic right between you and the AI. And that introduces regression bugs.
And for anyone not elbow deep in software, regression bugs are basically new code that accidentally breaks old code that worked perfectly.
Exactly. A shiny new framework update can easily break a reasoning path that Claude already understands natively.
That sounds incredibly frustrating.
It is. A feature that operated flawlessly on Tuesday just crashes on Wednesday because the framework updated its background logic.
I have to push back a little here, though.
Sure.
If you're building a $1 million company, trusting vanilla AI without heavy guardrails sounds, well, incredibly reckless. Doesn't a complex problem require a complex framework?
You would think so, but no. The core intelligence comes from the model itself. Wrappers just confuse it. If you want to prevent hallucination, you rely on the raw reasoning engine of the model, completely unbothered by third-party code.
Keep it simple. Let the raw AI do the heavy lifting.
Bingo. Build lean. And they actually use a brilliant minimalist trick to keep the AI focused.
The ploe.md file.
Yes. Have you used this?
I have. You just create a simple markdown document in your main project folder, and you list your fundamental project rules inside it.
Things like always use TypeScript or prefer functional components.
Exactly. And whenever the AI agent opens your workspace, it reads that file first.
It acts as a universal context window. It just anchors the entire code base.
It is like giving the AI a reliable magnetic compass instead of wiring up a heavy, glitchy GPS dashboard. It just points true north organically.
That's a perfect way to describe it.
Okay, moving on. We'll skip ahead a bit. So, you've built a lean, highly effective solution. You have avoided the cumbersome, brittle frameworks. Now comes the most uncomfortable part for a technical founder.
Oh, pricing.
Yes. How do you charge for it without underselling your value?
Pricing is where engineers always freeze up. They look at server costs, add maybe 20%, and write it on a whiteboard.
Right.
But Nick ignored paper math entirely.
Yeah.
He used friction-based pricing.
So he started by charging $100 a month per seat.
Yeah. And the HVAC owners bought it without blinking. The sales conversations were entirely too easy.
Which means money was left on the table.
Exactly. So he gradually raised the price for every single new prospect. He actively looked for the point where buyers started hesitating.
He wanted to hear no.
He needed to find the ceiling.
And today, Clairvo sits at $250 per seat every single month.
Yep. Let's do that math on a standard mid-market call center. A 100-seat team equals $25,000 a month.
$300,000 a year from just one single client.
The revenue scale of business-to-business software is just staggering compared to consumer apps.
Here's where it gets really interesting. The case study looks closely at companies like Jasper and Copy.AI as a massive cautionary tale.
Oh, absolutely. Their early go-to-market strategy was completely backward in hindsight.
Because they started by selling very cheap, low-touch web apps.
Right. $20 to $40 a month, aimed squarely at everyday consumers and freelancers.
But cheap apps die remarkably fast in the current AI era. If your product is just a thin wrapper around a $20 API prompt, your moat is zero.
Zero. When ChatGPT launched its free tier, the churn for those writing tools was astronomical. The cheap model breaks instantly under pressure.
To survive that extinction event, those companies had to pivot hard into the enterprise space.
They stopped selling $20 subscriptions and started selling $2,000 enterprise packages.
Because enterprise contracts include things a raw API simply cannot provide.
Exactly. Single sign-on integration, SOC2 security compliance, role-based access control.
They shifted from selling raw intelligence to selling workflow integration and security. But why are enterprises willing to pay hundreds of thousands for something built with cheap AI?
Because they are paying for risk reduction, security integration, and white-glove human support. They honestly don't care if the underlying API only costs a fraction of a cent per token. They care about guaranteed operational outcomes.
They aren't buying the code, they're buying peace of mind and trust.
Exactly. That trust is the entire, right? It is the ultimate fear in Silicon Valley right now. And the answer is building moats.
Defensive walls constructed entirely outside the code base.
Yes. The case study highlights several tangible examples of this. The first is the regulatory moat.
Let's look at the telecom industry specifically. You can't just spin up a server and start blasting thousands of phone calls legally.
No, definitely not. You have to navigate A2P 10DLC compliance.
Right. That is a strict telecom regulation requiring businesses to formally register their brand and their specific messaging campaigns.
It is designed to stop spam.
And Claude cannot legally register phone numbers. An AI agent cannot bypass strict federal telecom laws, and it certainly cannot sign legal liability waivers for your clients.
No, you need an employer identification number and a real human to file that miserable paperwork.
Navigating that bureaucratic red tape is actually a massive shield.
Competitors hate paperwork. It slows them down.
True.
Then there is the human implementation moat. Big enterprise clients demand dedicated account management.
They want a quarterly business review. They want an advisory board.
Exactly. Claude cannot shake hands in a corporate boardroom. It cannot hold a nervous operations executive's hand through a messy 3-month onboarding process.
Large organizations move slowly. They require real human empathy to guide them through technical transitions.
It's essential. Next is the data moat. Clairvo constantly collects historical call data from all its various clients.
Millions of data points on when people pick up, how long they listen, and what time of day is most effective.
And that proprietary data flywheel is incredibly hard for a new competitor to replicate. A blank off-the-shelf AI model is smart, sure, but it doesn't have the hyper-specific context of an industry's behavioral patterns.
And finally, there is code flexibility. You must build a model-agnostic code base.
Right.
To be precise, model-agnostic means code that easily switches between different AI systems without breaking.
This is a brilliant insurance policy against platform risk. You never lock your entire product into just one ecosystem.
If OpenAI changes its API rules or Anthropic experiences an outage, Clairvo doesn't die.
Nope. They seamlessly swap the underlying engine to Gemini or Llama.
The business never stops running. It is pure architectural resilience. So the ultimate defense against AI is actually being human.
Yes,
Yeah.
exactly. The human relationships, The legal accountability and the proprietary data are the heavy anchors that keep the software grounded in reality.
Wow.
You use the AI to generate the raw logical leverage, but the human elements protect the castle.
The uncopyable parts of an AI business are entirely offline.
The offline world acts as the ultimate armor for the online code.
We have covered some deeply tactical ground today. So what does this all mean? Beat. Building a highly profitable SaaS company today isn't about raising a massive seed round. It isn't about hiring a bloated team of 20 engineers to build a complex architecture.
No, it is about extreme strategic focus. You have to find a million-dollar pain point first, a red-hot problem that businesses are desperate to solve.
Then you leverage AI to aggressively brainstorm and simulate the operational mechanics.
Right. You keep the code base lean and vanilla. You avoid those heavy, brittle wrappers that introduce regression bugs.
You price boldly by pushing the market until you find actual friction.
And most importantly, you build real-world human moats to protect the entire system.
Claude, Gemini, and ChatGPT are truly unprecedented technical assistants. But your ultimate commercial success depends entirely on your market positioning.
And the tangible offline trust you carefully cultivate with your clients.
So, to you listening right now, stop drawing massive theoretical system architectures on whiteboards. Open your terminal. Find a logistical nightmare that is actively costing a traditional business real money today.
Start building the simplest possible solution. The barrier to entry has literally never been lower.
Just remember to pour concrete into those defensive walls outside the code. Your legal compliance and human empathy are your true fortress. Which brings us all the way back to that strange paradox we started with. The real secret of $1 million AI business isn't the AI at all. 2-sec silence.
Yeah.
It leaves me with one final thought to explore.
What's that?
If AI eventually gets so exponentially good that writing complex code becomes completely free and instantaneous, what deeply human skill should you be mastering today to ensure you still have a competitive moat tomorrow?